We're going to get started here. There's a few things to cover before the talk actually starts, so even if a few more trickle in, they won't miss the majority of the content. But this is obviously the first. This is the launch of this meetup. So just a quick intro to me. So I'm Caden Wilkinson. I am the technical co-founder at Ask Elephant, which is a local startup here. Our office is just across the way over kind of across from Harmons and Traverse and that Innovation Point. I previously came from, so many of you probably have heard of Divvy around here. I started at Divvy when it was, I think, 50 employees and like 17 engineers. We got acquired by Bill.com for $2.5 billion. And then I went from there over to Jasper AI, which was a generative AI company doing marketing. And that's when I really started working with LLMs in production. So I've been working with LLMs since like GPT-3 days-ish, and shipping those like pretty high at scale at Jasper. And yeah, previously I was also at Vivint doing some cool smart home stuff with cameras. I am a big GraphQL nerd. I have managed a lot of federated graphs at scale at both Divi and at Jasper. And I open sourced the Absinthe Federation library for Elixir for GraphQL and spoke about it at ElixirConf. And I just live here locally in Eagle Mountain. I do speak English and Spanish. I lived in Peru for 2 years. And yeah, here's some of my contact info on LinkedIn and Twitter and my work email currently. But yeah, I wanted to first talk about why I wanted to start up this meetup. I've actually had a lot of conversations with local businesses through just my network with, through my co-founder and his network and investors and the like. And a lot of them have been really interested to see like some of the things that we've been doing, and they've been trying to adopt AI more natively in their org, and they wanted to talk and learn. And I've learned a lot from other people that we've met with as well. And I felt like there wasn't really a space for a lot of us to come together and learn from each other about what it looks like to have an AI native engineering org. But I think there's a lot we could learn and teach each other. And I think one interesting way I heard it put recently, as we've been using LLMs for coding, is that it's been a while since I felt dumb because we have LLMs accessible to us all the time to help us solve hard problems. And I wanted to get together with a group of people and let you guys help me feel dumb again. So we're all trying to figure this out together. I don't think anybody has it figured out. And there's very large engineering teams trying to figure it out still. And I know a lot of us come from smallish companies. And so we have a lot to learn from each other as well. So that's kind of the reasoning why I wanted to start this up. It's been a conversation for a little while. I have three of my team members here from Ask Elephant as well, and there may have been a little bit of peer pressure for me to get this going, but it was good peer pressure. So, so a couple of things about what I feel like I want this meetup to be and what I don't want it to be. Obviously, I want us to learn from each other, and I want us to share what's working, but also what isn't working. Like, it's okay to talk about things we've tried that are not working, and I actually think it's really valuable to hear about that because there's a lot of hype around this and there's a lot of noise. And so we also need to talk about the things that are hyped up that maybe aren't really playing out the way people are expecting them to right now, and we should be talking about that as well. And then for what I don't want it to be, I don't want it to be like vendor, like demo hall, like we're not just here to demo like what our own software is and try and sell it to each other. I also yes, I want to shout out companies that are hiring because the market can be rough for those out there, and I want people to know where opportunities are that they can look at. But there's also, because we're trying to figure this out, there's also not really a right way. So yeah, and I don't want anybody to feel like they have to pretend that they have it all figured out when nobody does right now. So I wanted to start with a couple of questions in the room just with raise of hands, but start with this first one. So raise your hand if AI is writing more than 50% of your code. Keep it up if it's more than 75%. Keep it up if it's more than 90%. Keep it up if it's more than 100, or if it's 100%, not more than, but yeah. Okay. Yeah, and the next one is like put your hand up when one of these matches like what you feel like your relationship with like coding agents is. Is it you're using it for primarily autocomplete? Okay. Anybody using it is mostly just pair programmer alongside you, who's just delegating work, like large chunks of work. Okay. Who's using it for like a full-on like autonomous night shift where you're like it's running for like hours on end by itself. Okay. Who has killed an agent around before because it was going off the rails, or who's never done that? Okay. Who's done it a couple of times, and who does it all the time? And yeah, I mean, if you did all the time, you probably did this week. So, and then the real question is, right now, people with laptops out, who's running an agent right now in the background? Okay. Cool. So with a lot of that said about the intro to the meetup, I did want to start with a little bit of call out. So if anybody is hiring, I put this big question on here. I don't want the people that are hiring to actually answer this, but I just want people that are interested in getting jobs right now. I think this is actually a really important question to ask with companies you're interviewing is like, what is your actual AI budget that you can use when you go to work at a company? Because like there's a lot of discussions right now about what that looks like. And if teams aren't thinking about that, that's something that's useful to know. So is anybody hiring right now that wants to just give a quick little like what your company name is, what role you're hiring for people to be aware of? Just raise your hand if you do, if you are. Oh, it's not a good sign, guys. Okay, we'll keep doing that every meetup, so hopefully that'll change. Cool. Before I get into the talk, I want to just pause there for anybody that wants like ask any questions about that. I will have a QR code and stuff at the end for people that are interested in submitting a talk and wanting to come and speak at the meetup, and then also for people that are interested in sponsoring as well. So towards the end, you'll see those QR codes if that does interest you. But any other questions, housekeeping or yeah. Yeah, I can share these slides for sure. Yeah. I'll just export a PDF and I can dump them in the meetup channel in Utah.js is probably the place where most of us are right now. Is there anybody not in the Utah.js Slack that's here? Okay. Maybe I can I share those on through Meetup with people that have like RSVP'd and stuff? The slide deck or anything? I can send a message with like a link or something. Okay, I'll try that for those that aren't in the Utah.js. I'll try to send it out through Meetup for those that RSVP'd. So if you didn't RSVP, probably go to the Meetup and yeah, you can just join too. It's public. So and there's a Meetup channel in there where we announce the meetups, and then there's also an AI channel that has been way quieter than I feel like it should be. So hopefully we'll change that. But any other questions? Cool. I guess last little shout out. If you didn't notice, my shirt says MCP on it. This is shout out to WorkOS folks. Is anybody from WorkOS here? No. I know a few guys that work over there, but they design these MCP shirts, and you can go set up their MCP shop and order one for free. So if you're interested, it's kind of and that's not a sales pitch. I just like those guys, and I love the shirt. So cool. Yeah, so obviously this is the first meetup, so I just wanted to do more of a kickoff with an intro of what AI native engineering is, what it means, or what it means to at least me, and maybe what it means to you guys, and learn what it means to you. But obviously right now we're reshaping the software development lifecycle like dramatically. And I don't think it's a matter of like, is this going to happen? I think it is, and like that's why I feel like it's important for us to start talking about it. And I primarily this intro, I'm gonna like base it off of a paper that was published. Well, kind of a paper. It's more of like a case study from OpenAI that's called Building an AI Native Engineering Team. And they basically will go through all the different phases of the software development lifecycle and how AI is changing each of those phases. And then we'll go fairly deep into at least one of those, which is the phase that impacts us the most, which is the build phase. So one thing that I really like to call out is there's this research lab called METR, METR. And actually, I kind of want to show that page real quick. So if you haven't seen this before, METR, they're basically creating a list of a bunch of software tasks, and they measure the time it takes for a human to accomplish that task, and then they measure each model's ability to accomplish those human level tasks with like a 50% accuracy, and they also let you filter by like 80% success rate as well. And what they're trying to do with this is they're trying to track the trajectory of like the scaling laws of how good models are at solving like coding tasks. And as you can see with the timeline down here, like when GPT 4.0 came out, the task length that was able to do was like a task that would take a human 7 minutes to do, it could do with a 50% accuracy, which is not really that much, right? But this is also log scale. So if I show you the linear scale, it looks quite a bit different. But as we go further up here and we get up into, you know, Claude Opus, which isn't even the latest model, by the way, that task length is 12 hours, right? So like the time it would take a person to go do a 12-hour task, Opus 4.6 can accomplish that same task with, in this case, it says not just a 50%, but a 78% accuracy on a 12-hour human task. Okay, and this is obviously a trend line, and in fact, this trend line actually looks like it's not accurate based on where some of these models are. It almost seems like it's going to go steeper. And they previously estimated that the doubling of these times, like every 7 months, but in the last 6 months, it's actually 5x, so it's actually much faster than they even projected originally of how fast that's changing. And so, yeah, this has a massive impact on our software development lifecycle and what we do every day. And so I thought that's really interesting data that a research lab has published. I like calling it out. You know, it reminds me also, there was a talk from the chief scientist at Anthropic, and one of the pieces, they asked for him to give advice to like the audience that he was presenting to. And one of his pieces of advice that he gave to everybody is like, you people that are building with AI and with LMs, like you should be doing things that don't quite work. Like you should find things that don't fully, like you try a workflow and it just doesn't quite get there, because those you can create, like use those to create evaluations where it's like, I know this task isn't possible right now with the current models, but it likely will change here in the future. And so you need to like be on that frontier, because if you're not doing things that don't work, then you're almost already behind as soon as the next model drops. And so like I truly believe in that same recommendation as well, is like it's okay to try things with AI and like see it fail. But I think the concern that we have is that like, oh well, AI is not good enough, so I'm just gonna have to stick to where it is right now. But it's important to realize that like that's going to keep changing, and that you're actually finding the edge of that frontier, which is a good thing, and it's not a bad thing. So it's good to fail there. Yeah, so here's all the different phases that OpenAI's document breaks down: plan, design, build, test, review, document, deploy. We'll just do a quick one slide on most of these, and then we have a handful of slides for the build. So we'll go through each of these phases. So first, in the planning phase, which is kind of like a lot of the product aspect of software development, but also like the scoping with engineers. And so one of the pains that OpenAI calls out here is that like when we create these plans, a lot of times they drift from what the code actually is, or like the architecture or the infrastructure. And engineers have previously in the past been like the bottleneck for this scoping. And a lot of times we'll not give enough feedback early on in the life cycle until, you know, it's too late, and then it takes time to like rethink through some of those specs and acceptance criteria. Now with AI, we can change a lot of this process by using like coding agents that can read the spec, go through the code base, surface ambiguities for us automatically. Like in the past in my career, when we were planning out a new feature, a lot of times we'd create like these spike tickets, if you've heard that before. It's like designated amount of time to go and research and understand, like, if we were to build this feature, what are some of the things that I need to learn about how we're limited by what we can build, so that I can come back to product and be like, here is what's possible, but this thing that you wanted isn't quite possible unless we spend this amount of effort, right? But now we can do that a lot more quickly by delegating a lot of those tasks for the agent to go and traverse and do a lot of that planning in advance and uncover a lot of those ambiguities and dependencies to find, like, well, in order to do this, we need to do this and this, which speeds up a lot of that process. So this is kind of the format for each of these phases in these slides. So we're gonna talk about the pain changes, and then the concrete moves is like, what things can we do today to help start applying AI into this phase of that development phase. And so in this case, it's like wiring up an agent that does like triage to your issue tracker, so that like when a new ticket comes in, an agent can actually pick that up and go do a bunch of research automatically and triage that and add a bunch of research to that ticket automatically without somebody else needing to come along and like fire that off itself. Like that, you can kick that off autonomously in the background. And there's a lot of ways to go do that. And towards the end, when we have a little bit more free-form discussion, I'd love to talk about like maybe what some of those tools are that like we're using or what you might be using that we can dive a little bit more into. But then also, like, once it does those research, you can even, if you want to use, if your team's small enough and you want to just use like version control, you can also just like create plan directories and like go and plan those out and actually commit plan files to your repo. But the challenge with those is they can become out of date pretty quickly. So using like the linear tickets, they're usually tickets in like a ticketing system are pretty short-lived. Yeah, you can even do like risk analysis and stuff in the plan phase as well. So that's kind of the plan phase. If we go into design now, so we've done all this research with AI on our tasks and uncovered a lot of the dependencies and the ambiguities, and then we're handing a lot of those plans off to design to go prototype some UI or UX around this experience or this feature, now that we understand what the limitations are and what the scope is. And the trick with that in the past is that like the design to engineer handoff has been fairly messy at most companies I've worked at, and a lot of that has to do with, you know, having almost a different language that you're communicating with to each other. And a lot of that's kind of the primary reason why like design systems became like a very strong thing, is like consistency, but also to create a unified language for designers to talk to engineers about things that they're doing. And you know, now in this age of AI, and we have multimodal agents and models that can actually see pictures and understand like what something looks like and how it behaves and like navigate in the browser, we can actually have agents go and build like prototypes for full-on features that even are built on top of the design system. So it's already built on the reusable components that we're already applying into our product in production. And that allows us to even like create multiple prototypes a lot faster and like see variations of the same user experience, which is good for our users because that means that we end up getting a better outcome for our users, because we can test more ideas faster and get the best experience for users long term. And so now, how do we apply that right now? What are the things that we should be doing? So if you have a design system, you should definitely make it accessible to your agents. And you should also make it to where you can have designers and PMs like actually have access to those components and like be able to prototype them. You may have seen recently like Claude Design, where you can actually have your designers create like your design system in Claude Design. And then that allows them to like prototype ideas in Claude Design. Now the trick there is like if you have your own design system, they're kind of like recreating it from scratch, and it's probably not going to match one-to-one. But there's a lot of ways for you to expose your design system to agents so that your PMs and your designers can work faster and test more ideas and theories out. And the cool thing is like you can do high fidelity now too. You don't need to do wireframes first and then go to like a high fidelity afterwards. Now there's benefits to doing wireframes still. I'm not a designer by any means. There is value to wireframes, and Claude Designer actually does support doing wireframe designs before you go to high fidelities because there still is value there. But if you are on a small team and you don't have the time to necessarily do wireframes, you can just start with high fidelity and do it quickly, and do that early, which is great. So yeah, that's kind of the design phase. And then here we get into the build phase where like the meat of this is going to be. So a lot of the pain we've all experienced is that the build phase has been a major bottleneck in the past, right? Writing code was fairly expensive, and there's technical debt we have to take into account as we're making decisions for like how to decide what scope should exist. And most of the time we were spent doing like mechanical work, right? We're like, take this thing that works this way and translate it directly. We weren't being like very creative problem solvers. And I think a lot of us chose this career because we are creatives and we do like solving problems. We don't want to just be given a spec for a task that's like it should work exactly this way and then we have to build it exactly that way. I think a lot of us, at least myself, one thing I've learned as I've used AI more is that I've realized that I am more of an artist and a creative than a logical thinker than I believed I was for a long time. And part of that I think is I used to take a lot of pride in designing and creating solutions to like coding problems and technical debt, and that was like my canvas. And the more I use AI and the less I write code myself every day, the more I have to lean on, the product itself is now my canvas, right? Like that is now the thing that I use to produce that art and put it in front of people. And the way that it impacts people's lives is now the value that I get in return for seeing that, just like I think an artist does when they create a form of art. They like seeing how other people respond and how it makes them feel. And I realized that as I've typed less code every day, I've started to focus more on that aspect of engineering and software development. And that's been an interesting shift to adapt to for me. But the cool thing is it actually enables us to do more of that. Once I came to that realization, I was like, I can let go of writing the code because now I get to focus on my canvas. I actually get to think about this art form differently now. And with agents, we can, draft entire features end to end, put out data models, architecture, APIs, and review what those might look like. A lot of people have been concerned that people aren't going to be able to learn as well with AI. I actually get to learn. I feel like I get to learn a lot more about things that I never had time to learn about before. A lot of companies, you have these domain experts that like knew the most about a specific area of the product. And a lot of times you'd have to go to them to get their feedback. And I do enjoy those conversations still. But I can also do a lot of my own investigation and understand that myself and learn a lot too. And then I can take my own learning and talk to the domain expert. And a lot of times I'll even find new ideas that they haven't even thought about now. And like I never would have imagined being able to do that before because it was too time consuming to do that. So some of the concrete moves we can do right now in the build phase is, if you're not using ways to guide and give guardrails to your agents, via Agents MD, and having like rules defined to help tell the agent, this is like how my architecture works. This is how we've architected it in these layers, and code that touches the database should live here, and code that's coming in from the API should live here. And you can start thinking about the bigger picture in the system design and give a lot of that guidance to the agents to then follow that. And I think it's helped me become more of like a systems engineer and more of an architect than one of those engineers that's doing the mechanical work of feature spec to feature build. which I think is actually really exciting. I actually think that's really cool that our careers are changing in that way. So as we go in a little more depth, this is a little bit more detail about us as a company and how we're doing things differently in this build phase. This might sound a little crazy to many of you, but we actually have non-engineers contributing code to production at Ask Elephant. And an example that I put here is we had one non-engineer that merged 30 PRs in the course of 5 days. That was tens of thousands of lines of code. Now, all our engineers are reviewing all of this code, and we also have 30 CI checks that run on every PR, and that's growing rapidly. And we also have 2 different AI code review bots that are using like different models to get different perspectives on things, and looks at every commit, and will go back and forth many times before a human even ever starts taking a look at a PR. And our budget, because this is not cheap to do this, but we right now basically have like a budget of like $1,000 per engineer per month right now in token spend across the org. Is that a hand raised back there? Sorry. No, that's like token spend across vendors, whether it's like Claude extra usage or ChatGPT Codex extra usage or Cursor. We do use a variety of different tools, and I can talk more about that too later. And I also wanted to call out that it's not just rainbows and roses, because we also had some incidents as a result of that. In this case, there was a degraded performance on like one of the things we do is we record a lot of conversational data, like meetings. Like I actually are using our product in the background to record this meetup. And we had some degraded performance where like those processing around those meetings was getting delayed by a decent amount of time, and customers were reporting that like, hey, I finished this meeting like 20, 30 minutes ago and I'm still not like seeing it show up yet in the UI. But another side of that too is that like when that incident happened, we also were able to use agents to help triage this and find the actual PR that introduced the issue and like when it started, which was also really helpful, and I think made us faster at resolving those incidents as well, which was kind of cool. A couple of the choices that I think we've made that I feel like have played out pretty well for us, and I also happy to argue about these because I don't think that we're completely right, but at least it feels like some of these things have been good decisions. But we primarily have a fairly large mono repo where like all of our code lives in one place. One of the benefits to that is it's allowed us to manage kind of like one set of rules and one set of tooling for our agents to use, which has been easier to like tune things and get it working really smoothly and well when like most of that stack is like very similar and is all in one place, and we don't have to replicate that or figure out how to replicate it across different things. So that's been good. We also are, so like a lot of we've been doing a lot more parallelization of agents, running more than one at a time on the same monorepo. And we've obviously run into challenges with that, like port conflicts. And so we are also in the middle of like trying to figure out cloud agents as well, so that we can parallelize work more without creating conflicts between these different environments and cloud agents, which has been, we're still early stages there, but I feel like there's a lot of wins we're going to see from that. We are also a TypeScript shop, full stack, so typed languages creates kind of a feedback loop to agents. So as the agent writes code, it's going to be able to run the TypeScript compiler, and thank goodness they preemptively decided to rewrite TypeScript in Go, because we're going to need it with all the code that's going to be created with agents and how slow it is. And so we need that 10x boost in compile times. But having that feedback loop to the agent has also been very valuable. And one of the things as engineers we spend time on during planning is kind of designing what those APIs should look like in the types. But then we kind of leave it up to agents for implementation of those like interfaces. And we're also trying to make more progress to do more of that as well. We also learned that as we did more agentic coding, we realized that the feedback loops to agents need to be fairly fast. And so we quickly realized ESLint was too slow for feedback loop. You know, if you're running a task that runs for an hour and it's running linting after every file edit and your linting takes 40 seconds, like that can add up quite a bit over time. So we migrated over to another tool, Biome, and there's also like other like OX format or OXC format that are all written in Rust that perform a lot faster, and our linting went from like 40 seconds down to like 2 seconds, which as you're doing a lot of those loops, that is a lot of time savings. And then we've been talking about doing a little bit more of like a TDD approach as well with our planning with agents and using tests as specs as a little bit. We're still early in the conversations there, but I would love to talk to other people that have maybe tried some of this more like spec-driven development or test-driven development with agents, where you are more involved in the early stages of defining the specs and the tests, and then hand it off to agents. So that's one thing I'd love to hear more about from other people and what you're seeing. So yeah, that's kind of more of the build phase, and then we can get into the test phase. Obviously, in the past, many of us have been put under pressure of deadlines, and you know, when you're talking about reducing scope, one of the first things that always gets reduced in scope is automated testing. And also, you know, when you're under pressure, even if you don't cut scope on tests, you'll usually write them too fast, and you'll not write good tests that actually provide value. I actually have a background in QA. I started my career in QA, and I went to GTAC, which is Google's test automation conference. And one of the things I thought was crazy interesting that they were doing at Google around testing and QA was they created this concept of what they called mutation testing, where they would actually take your code under test and dynamically change operators from like a plus to a minus or divide to multiplication. And then they'd run the tests after they changed the code that was being tested and see if the tests fail. And if they didn't, they were like, these tests are bad, because if you change the entire behavior of how the app code works and the test still passes, that test is not providing like hardly any value to you. And so I think that, you know, now it's getting a lot easier to write tests, but agents can also write very simple, not valuable tests as well. And so I think it's important to like have dedicated agent phases in your development lifecycle to they're like trained and tuned by maybe somebody that is an expert in QA to understand like what is a good test, instead of just having AI spit out like, you know, vast amounts of tests that don't provide any value, that then are increasing your feedback loop time for your agents that are running them locally, but also in your continuous integration system that's running your automated tests as well. So yeah, as far as like things that you can do, yeah, I mean, it called it out here, right? Generating tests in a separate session with an agent that's designated for writing good tests and validating which ones are good. Being able to have code coverage like CI checks, where you're like, I want to measure what our coverage is. One of the favorite things I did recently with testing is I had an agent go through our code base and Git and version control and find the hottest files in the code base, which means like, what are the top 10% of files that are being touched the most frequently by engineers? Like they have the highest churn, like which files are being touched the most, and then created a list of all those files. And then I ran tests with code coverage report and said, okay, now what is our code coverage on these files that have like high traffic areas where like there's risk of regressions? And found that like a lot of those high traffic files had like very little tests in them. And it's not obvious to you as an engineer or to your agent, like which file is a hot file that's being touched frequently. And so being able to use agents to do that research quickly, because, you know, if you did that yourself, that could take a decent amount of time to figure out what those files are, and then take the report on your coverage and then, union those together. But now it becomes easy to like find that tech debt around your like QA and your testing process as well, and help make sure that your tests are actually high quality and you have the coverage where you need it. And find areas that maybe you could cut some tests because they aren't as needed or providing as much value. Yeah, and then there's some other tools like plugging it into, just giving your agent instructions for how to use a CLI to get the code coverage reports, or MCP as well. But most test runners will have like a standardized format that you can use to export those. That's helpful. I know that also we have Ivan on our team that has a pretty heavy background in QA, and he's worked on training some like skills for agents to help understand, like, given a change set, what is the risk involved in those changes. And it can even give you a list of like things that you should test manually, or your team, which is also super helpful, because if you can come up to a PR that was created by a non-engineer on your team, and then you can just fire off a skill at it that says, hey, go and review all these changes and tell me the highest risk things I need to go test myself in like my staging environment, or whatever environment you have to go test that, then that gives you a lot more confidence too, as you're testing other people's changes that might not understand the impacts of the things that they're doing. And then you can even start to like automate that, include it in your automated code review too with AI, where it will just dump a list of like, here's what should be tested as well. And then review. This one's also a hot topic, because the throughput here, I don't know if, I'm sure a lot of you have felt this, but the throughput of PRs has kind of been insane over the last few months. And we've been thinking through a lot of ways of how to handle that throughput, because even without our non-engineers contributing code, even just our engineering team itself is contributing a vast quantity of PRs that they weren't before. And so this is only getting more and more difficult over time. And one of the ways that a lot of things are changing is AI is also really good at reviewing code and understanding it. And so leaning on code review topics. Hopefully people aren't getting stuck in the waiting room. I just heard a beep, but I don't know. We'll see. But yeah, having an agent that's also trained specifically for code review too, that's not more of like a generalist, just coding agent. There's a lot of them out there. Just to name a few, there's like CodeRabbit, BugBot, Greptile, Codex. I mean, you can use Claude Code as well. There's a lot of, and there's even a lot more than that too. Intelligence as well. Now, I would experiment with them, because some are definitely better than others, and we've probably gone through a number of them and turned some of them off and adopted a new one that we felt like was giving much more valuable feedback to us. I really like OpenAI's request here to like create a gold standard PR list, like a set of PRs that you are like, these are really good PRs, and use that as like an eval set, where you can say, like, if you want to adopt a new AI code review tool, take that new AI code review tool and have it go run on like that curated list of PRs and see how it does in comparison to like some of those other PRs. So I thought that was really interesting. And then it looks like they're also recommending like tracking PR comment reactions as a quality signal. We're not doing a lot of that right now, but that is really interesting. It probably matters more in like larger orgs where many humans are reviewing a single PR. Our team's small enough that we have one human reviewing each PR. But yeah, we don't have any automated merge process. Like, there's no way for AI to like approve itself and then merge and then go straight to prod. I feel like, at least for us, we have a ways to go before we get to that level of comfortability. But these AI code review bots are kind of like the first line of defense. And it's not just like the first pass, but like first pass and then agent follow up with those comments, validate if they seem like they're like another agent reviewing them and saying like, yes, these comments from this AI code review bot like actually seem pretty valid and probably should be addressed in the scope of this PR. And then they'll maybe push some fixes up, and then another AI code review will come down second pass after the next commit, and like it can go back and forth a number of times until all the comments from AI code review bots are done, they've all been resolved, and then now a human can come in and like take a look at the whole PR that's already had quite a few issues already reviewed and addressed before even a person even took a look at it, which has been one of the ways that we've been able to scale this, at least on our team, with the throughput. Let's see. And then the documentation phase. Documentation has notoriously been something that's been hard to keep up to date in code bases and like product knowledge bases as well. And they decay very fast. So, with agents, we can now create automated ways to like keep docs up to date. And we can guide our agents to help us manage that. We also we have tooling that will audit changes being merged and create like release notes and change logs that we can then review and like publish to our customers, which has been and there's a lot more we would like to do there too, like even the automatic creation of like product knowledge base documentation for our support team. And then, our AI support agents are like also reviewing those docs and answering questions for customers autonomously. There's like ways to just like chain so many of these things together to just automate processes all over the place. And yeah, one of the things that we've found that's been really good, at least as far as like prompting with these plans and the documentation and like even the tickets that we build for agents that are going to work on them, is to focus on documenting the desired outcome and not the like it's more of like I guess it's more of the why and the outcome, not necessarily the how, because agents are actually really good at trying to figure out how to solve as long as they have a good outcome that they're driving for. And a lot of times when you're too specific about how to solve a problem, then the agent will get too stuck on what you told it, even though it might find another better path than you would have even thought of. But it'll be like, well, the user told me that they wanted to do it this way, even though I know I could probably do it this way and it would be better. And so if you describe the outcome and use that in your like tickets and your documentation for your plans, then it also helps those stay more relevant longer, I think, because a lot of times when they go stale, it's because they're very specific about the implementation itself, and the implementation changes all the time. And so when the implementation changes, the documentation is out of date. But if it's more about like the why, the outcome, a lot of times that doesn't really change, but that's the thing that actually matters the most long term when the next person or next agent comes along. When it's thinking about changing the behavior of something, it can say, well, hey, we have this other outcome here in the documentation that was like, we did this way for this product reason, and that's like pretty helpful. And then the kind of the last phase is the deploy and maintain phase. So when we ship software, things are inevitably going to go wrong at some point, and incidents are going to happen. And the challenge with incidents is like, the goal is to find out about those incidents before your customers do, and then address those incidents as quickly as possible to reduce customer impact. And so some of the things that we can start thinking about with agents now as we're in this AI native engineering world is, how do we use AI to both detect issues before customers do, but then also help us fix them faster than we could otherwise. And so some of the ideas are like giving your agents the ability to like query your logs and find review which PRs emerged recently, maybe your error tracking from whatever error monitoring tool you're using. You're also feeding that to agents that are like, hey, new error showed up that didn't exist before. Let's fire off an agent to go and triage this new issue and research it and possibly create a ticket, and then maybe even open a draft PR that's like, hey, new error popped up in production. It didn't exist before. Here's now a draft PR that addresses this that you could go review, and here's the ticket around that. And that allows us to like find errors preemptively, even hard to find errors, because a lot of times, like even in the incident case that we had where it was like degraded performance, like things were getting processed, they were just happening slower. And so, you know, using agents to help catch that sooner than, because we're not like humans, we don't have time to sit there and observe dashboards all day, every minute of every day, right? But agents have the patience to do that. So yeah, also like obviously tracking audit logs and staging environments where you can give agents even more freedom to do more reckless things with low risk to your business and your customers is also helpful. Let's see. Also, even just giving your agents access to some of the like logs in production is also very helpful in like the planning stages, and also is really helpful for technical debt. The non-engineer at our company that contributed that many PRs, a large chunk of those PRs were actually helping with resolve technical debt, which is usually something engineers only care about, but they were able to, because we created a safe way for the agent to go and pull logs from our production instance, they were able to go and find like what are the most common errors that are happening across our system and start to understand why those errors are happening and start to resolve them little by little. And as a result, we actually resolved a decent amount of technical debt and found problems that were happening to customers that were probably pretty infrequent, but we weren't aware of because they were happening so infrequently. Users were probably not going to report them to us, which is also really cool that we are catching stuff that we would have never caught unless somebody told us about it, or somebody spent the time to go dig through your monitoring and observability tools to then go find those error reports. And then this kind of like follow-up phase, a cautionary tale. If you haven't seen this recently, that went a little bit viral. There was a company called Pocket OS that here in April had really bad guardrails in place and had an agent go and drop their entire production database and all the backups to that database in production in the matter of 9 seconds, which, unless you're watching that very closely, very astutely, 9 seconds is not a lot of time to catch your agent and stop it from doing that. There was a lot of reasons why this happened. It wasn't like purely the engineer giving it like unfettered access to this environment. Now that was one of the problems, but their cloud provider made a bunch of mistakes too, where their backups were stored on the same volume as the prod database. So when it dropped the volume, it dropped the prod database and all the backups, which is not great. But yeah, so one of the lessons here is that like, in order to avoid these kinds of situations, because they can inevitably happen if we're not careful, we need to think about, you know, security principles like least privilege, and that is something we need to like put a lot of effort into when you're trying to move this fast. Because if we don't, then like things are going to end badly. And so for a while, I've had these conversations with my team and a lot of these companies I've talked to that it's kind of felt like we're at this fork in the road where we're accelerating the amount of code being produced, and we can either start to really focus on, you know, guardrails, architecture, and putting all these things in place to help us scale up as we're creating more code, or if we don't, then things are going to go out of control and we're going to like lose control of those systems entirely. And I compare it very closely to some of my experiences at like the last 2 jobs I worked, like Divvy and Jasper were both very high growth companies. You know, Divvy in the matter of a couple of years went from 50 employees to like almost 400, and our engineering team grew dramatically. And as we grew that team dramatically, we had to start thinking about how do we scale up this many people contributing to these code bases, and what are the guardrails we need in place for the people contributing. And it's the same principles now, but in the context of agents. Agents are now scaling up and contributing tons of code, and we have to think about those same guardrails. But in the past, you didn't have to think about that unless you were at a high growth company that was scaling up very quickly. And if you haven't seen that before, you might not even be aware that like you need to prepare for that unless you've seen it. And so I think that that's one thing we should be talking about more, is that like even companies that are fairly small and not growing like headcount heavily, the amount of code with agents being produced is very similar to if you like doubled your team size in a matter of like months. And so like you have to start thinking about it in kind of those terms and put effort there, or it can get out of control and you'll lose control of the direction that goes. Another thing, these are kind of like just some meta themes outside of those software development phases that we talked about, but you may have heard a lot of conversations about people talking about, well, you know, tokens are very subsidized right now, and it's not always going to be that way, and they're going to get more expensive because they need to become profitable. And one of the things we've learned as we saw the recent announcement with Anthropic and SpaceX and xAI is that like the reason they were like lowering rate limits is like it was actually compute constraints. It wasn't like profitability concerns. It was actually like we don't have enough servers, so we have to reduce how much people have access to, because otherwise it will fall over. Like the infrastructure will just fall over. And the other thing that we need to take into account is like some of the new models come out, they have higher prices. Like GPT-5.5 is, if you look on paper, it's as expensive as Opus, and that scares people. But if you really think about it, like GPT-5.5 on medium thinking or reasoning is the same intelligence as GPT 5.4 on extra high reasoning, and is actually like the same price. And so like the price of intelligence per dollar, even though token, like the model is bigger and more expensive, the intelligence per dollar is still going down, and it's going to continue going down. And for a lot of tasks, you don't need the most intelligent, most expensive model with the highest reasoning to do a lot of tasks. And so if you're using lower reasoning, you can actually save more money than you were on a previous model with the same amount of intelligence for a different task. And so I just wanted to call that out, that I think that it can be a little bit misleading and confusing when you see those things out there. And I think it also helps kind of like arm you for the conversations with your finance teams or whoever's approving budget for those things, where it's like, you know, you can use that as an argument to help have those conversations. Cool. So that was kind of like the majority of the talk and topics I wanted to cover. Let's see how we're doing on time. Perfect, actually. And so then I kind of want to move into more of like an open mic discussion, Q&A. I want people to bring your own questions as well, but here's some like seed questions. If nobody has any questions, I can dive into these. But I'd love to just start doing some like Q&A and discussion now, talking through some of this. So yeah.
How do you guys handle the planning? You said that some teams ship the plans with the repo, some teams have MCPs. How do you do it at
I think that's one of those phases we probably are experimenting with right now. I think we have a few different methods that we've been trying lately. I would say right now the most common one is Brian created an internal tool that has we call it the AI Council. And it's basically like you give it two different LLMs. So we'll have like Opus and Codex, and one of them will like, you can ask it questions and help it with planning. You're like, hey, I'm trying to plan out this task. You can have like the worker agent go and try and do a lot of its own discovery for that plan, and then come back with a plan. And then it'll hand it off to another model as like a counselor in the council that will then like review that model's work and say like, is this good? Are there other things that it needs to be aware of or needs to rethink? And we'll have it go back and forth a few steps, and it helps refine the plan a lot. And model providers and models from different providers are very different from each other. If you haven't felt that, you should use other model providers. If you haven't used them heavily, you should use them to understand the differences and the trade-offs, because yeah, they behave very differently, and they have different use cases where it makes a lot of sense to use one model versus another model. I think a common one that like a lot of people know is that like 3D models are really bad at design, right? Like if you're trying to design UI or UX interfaces, like OpenAI models are not very good at it. Now you can make them better with spending a lot of time with skills and other things, but Anthropic models are much better at design. And so like for those tasks, it makes a lot of sense to use those models for design. But there's also a lot of other use cases that we, at least on our team, have found that like one model is much better at than others. And so having the counsel of like different perspectives from the model themselves to help during that planning phase has been very valuable for us too.
You guys store them anywhere, or they kind of just walk on the back?
Yeah, so we do, most of them are just like in our ticketing system. So like we'll create a ticket and then store a lot of the like plan and history of like that in the ticket itself. A lot of that like counselor back and forth chat history, we don't necessarily store that in like a centralized place. It is stored on disk in like a get ignored directory for each dev. So if you wanted to like review the thought process, you can. And I have put I've had some thoughts lately that like that chain of thought that gets you to the plan is actually also valuable. If you haven't seen, there's a company called Entire being spun up that is created by the ex-CEO of GitHub. And one of the things that he's doing is he created a plugin to Git where it will actually, as you're working with your coding agents and committing code, it actually tracks the history of your conversation alongside your commits as metadata. So you actually have the history of the conversation you had, as well as the changes that the agent made. And like over time, that data is going to be really useful. And so I think that is something to think about, is like that chain of thought process around how you do the planning, as well as the outcome and the plan itself, I think are going to be valuable. But yeah.
Yeah, I have a question. Sorry, I guess I can talk a lot about it, but
I probably should repeat the questions, but yeah.
It seems like there's a lot of context that you guys are dealing with, plans and logs and all sorts of stuff. What are you guys doing to like make that available all at once? I don't know if I can explain that. Is there some kind of like way to centralize all that so that you can have full context of everything that's going on as you're making plans or as you're looking at the thing?
Yeah, so a lot of the term that a lot of people have been using for this is like context engineering.
Yeah.
And the challenge with context engineering is that like, yeah, your data is scattered in a lot of different places. MCPs are very helpful for that. We've also been leaning a lot on CLI tooling as well. It scales up, we think, even better in some cases.
Not how it scales, how are you?
So like with MCPs, so you have a context window with your coding agents that can fill up, and there's this also another term. There's a lot of terms if you haven't heard them before. Context rot, which is basically like the longer your conversation thread gets with your agent, the like more that context gets very large and begins to like rot, and the quality starts to degrade on the output. And the challenge with like MCPs has been that like they can create like a lot of pollution in the context window if not done properly. And a lot of tools like Claude Code and others have like, they now have this concept of like tool searching, where they won't make all of the tools and MCP servers where the data and the context lives accessible to the agent out of the gate. But when it decides that it needs to find a tool, it can then search them. And then once it finds it, has access to it. And that helps reduce the amount of that window being used up and eaten up, and reduces the chance of that rot happening too soon. But CLIs but that's something custom, like that tool searching is something custom that you have to build, or you have to use like an agent harness that has that supported out of the box. And if you don't, or if you're building your own custom in-house thing, then like CLIs is kind of like the way to go, because that's like agents are just really good at like using shell commands and like using a CLI and running help to like understand how it works, and then calling commands as needed. And so I would say like, yeah, if you're using an agent harness that handles MCPs really well, you might not need to lean on CLIs. But if you're doing something more custom, like your own custom cloud agents or something, then you might want to lean more on like CLI tooling for a lot of that. Or yeah.
Then sorry to
No.
follow up, but do you have like a single point of contact that will find all that context wherever it's scattered?
I mean, not necessarily. So like we have like server or CLI for ticketing system linear, right? And then we'll have like, we have the G Cloud CLI, which is Google Cloud's CLI that it can use to access observability like logging and error, like tracing and error reporting. So we have a variety of like different sources that get aggregated together. Yeah. So I wouldn't say we have like one centralized place where it's all just like bundled up together into like one big massive like MCP server that like abstracts all of it away or anything. Yeah, I think I saw another hand before that over. Yeah. Yeah. So question is around like where are we delegating agents, like for even like for cloud agents. So many of you may have heard that like companies like Stripe, Coinbase, Ramp, they've been building like their own custom in-house cloud agents. Stripe's I think is called like Minions, Ramp's is called Inspect, Coinbase is like Dev Boxes or something, I can't remember. But these are massive teams, right? Like they have a lot of resources to go like build these cloud agents out. You also have Cursor's cloud agents that have recently been gaining some traction. There's also a lot of like sandbox providers out there. Vercel has like Vercel sandboxes. You have Daytona as an open source company that has like cloud VM sandboxes. And a lot of these sandbox tooling, you can just like spin up these almost like VMs, but they're almost like a little bit more lightweight than a VM. And you can just install like the coding agent harnesses in those, and then you can take like a snapshot. It's almost like if you had a Docker image or something, or you had a computer that you went and installed a bunch of dependencies on, and then you just froze it in time. And then later you're like, okay, now I want to like reboot it back to that exact same state. Like you can do that with a lot of these sandbox environments. And so like building your own cloud agents, like we played around with building our own. We're also playing around with Cursor's cloud agents. And there's some challenges like Cursor's cloud agents don't have preview URLs. Like there's no way to expose ports. So like if you have a service running in the cloud agent and you want to like send a preview URL to somebody on your team to like play around with a prototype of a new idea that you had, there's no way to do that with like Cursor's cloud agents. But like a lot of sandbox providers support preview URLs and like port bindings. So then you can like run an app in the sandbox and then have a preview URL and then like send it to somebody, and then they can just like pull it up in their browser and like test it out with like seed data and stuff. And so that's kind of why we're playing around with multiples, because like it's not a solved problem yet. And like, right now only massive companies with massive amount of resources have been able to solve it yet. And so I'm excited for like some of the new developments that are happening, and hope that it's something more accessible to smaller teams that makes that like more streamlined. And I think Cursor's on a good track to help solve a lot of that, but there's others out there too. So yeah.
When you're teaching your team and people are learning how to use AI in the workplace, how do you make sure it's not between them and the agent, that everybody can benefit and the whole team can progress?
Yeah. So how do we level up our team and their use of AI so that our learning isn't siloed? Does that sound like accurate? Okay. Yeah, I would say that like we can do better, but we have done lunch and learns like in the past where we'll like just schedule time and have a topic and teach it to the team, record it for those that can't be there as well. So yeah, so we do like lunch and learns. Yeah, Cody, you want to add something, or you? Yeah.
But after you're done, share skills.
Yeah, I mean we share skills. A lot of the same tooling. We help onboard people on our teams, because some of this tooling is not super streamlined yet, and so it kind of takes an engineer to handhold a non-engineer to get it like set up and running. Teaching version control to people that like have never written a line of code before is kind of challenging. And some of the things we do is like write skills to help manage version control, where we can just give them a / command that's like new branch, and they just run that, and then the agent handles the version control for them, so they don't have to think about it. Or like pull latest, and then it will handle like pulling from main and resolving merge conflicts. Like there's things that we do to help streamline it for people that aren't as technical and make it more streamlined. But I think just getting them to do it, they'll learn a lot too. An example of this is we had the need to revamp our marketing site recently, and we hired a new VP of marketing, and he's like, in the past, this has taken me like a full-time hire in like 1 to 3 months to like go redo the marketing site. And us as a fast-moving startup, we're like, we don't have that kind of time. So what are we gonna do? And so I went and like set up the basic platform of like, okay, we're gonna host this on Vercel. It's gonna be a Next.js app. We're gonna have a GitHub repo for it, and then we're gonna get it set up in Cursor with a bunch of these skills that'll make it easier for them. Got a lot, and then connect up a CMS, where they can manage all the content for the blogs and everything, and get like the foundation laid in advance. And then once it felt like it was like ready, I could then take a few minutes to get them like install Cursor, get the repo cloned, show them the / commands that they needed to use. And then once I showed them those commands and showed them how to use it, and they had Cursor and an agent that they could just work with, we had 3 people that never written a line of code before in their entire life rebuilt our entire marketing site and launched it in like a week, which is like crazy. And like we're seeing just like lots of things like that happening, and I think that like they're leveling up dramatically too. And like one of them was an intern that like just barely like out of like high school, getting ready to go to college, and he's now become like a pretty good expert on like what's called AEO, which is like not search engine optimization, but like if somebody asks a question about our market, do we show up in ChatGPT or do we show up in Anthropic as a recommendation? And how do you like boost your rankings on that? It's like a completely new thing that didn't even exist more than like a year ago. And like once we got him in there, he started learning all that from the agents and doing research on his own. And it's kind of crazy. Like he's probably one of the few people now that even understands how like all that works. And like that's pretty cool. Sorry, yeah, Cody, that was long-winded, but
I'm glad you got it. If you think about it, humans teaching each other stuff and learning together is very similar to the problem of context engineering, right? It's all about taking knowledge that's in a human's head and getting it out of their head and accessible for someone or something else, right? The difference is that agents are actually more consistent about looking things up or spreading it. Humans are a little harder, we're a little bit more stubborn that way, I think. So the more you can externalize, writing down, documenting ADRs and sharing with them, verbalize, writing scripts that do common workflows for you with something like Claude-P so that you can just automate certain workflows without having to build out a whole infrastructure, things you can check into your repo. There has to be person-to-person communication about these things, because if it's just a newsletter that shows up in Slack every week, like I'm the first one to skip those, you know. But the core of the core solution is getting it out of people's heads onto somewhere for other people to make use of.
yeah, well said. Other questions? Yeah, right here.
The engineers are sharing that Git repo. Do you have a problem with most of the other zones? More code being written?
So our team right now, we have 5 engineers plus a handful of non-engineers contributing right now. I haven't checked how large the code base is recently, but I think the last time it's growing fast. But we do have, we have a mobile app, we have a desktop app, we have a web app, and then we have all of our like backend and APIs. And then we have some internal tooling, like we have a custom in-house CLI that we use for internal tooling for like developers and our teams. And then we have like a control plane, like web app for internal things that we were playing around with for like cloud agents. So it's like, and then like a lab environment as a playground. And that's like the majority of what our monorepo is. It's a spread of projects, but yeah, we do have conflicts sometimes. I can't remember the last time I had to resolve a conflict myself with agents now.
I
Like,
was trying to say the biggest pain point right now is just Drizzle migrations, which is when people decide to do something in our tables at the same time. But other than that, it's.
yeah, DB migrations with a large team and people making changes to the database a lot is challenging no matter what tool you're using, I think. And I've seen that at scale with just large engineering teams before we were using coding agents as heavily too. That was also a problem. But yeah, I think that's like, as I talked about, like we're becoming more like systems and platform engineers. Like one of the things we have to think about is like, if you're, looking at high traffic files in your code base that are hot, you could also be like, how can I break this file up into different pieces to like reduce traffic in this one file? Because like maybe there's two separate pieces. There's actually ways to help architect systems to also reduce, and code bases to reduce conflicts as well. So I think that's also just part of like how we need to start thinking about things too, is like if you're having massive pain points in specific areas with conflicts, like maybe need to rethink like some of the architecture and of that part of the code base even. So, yeah, again, what do you got?
mentioned local models. What kind of hardware are you running on that when you bring them on, and what kind of models?
We're not actually. I might have been came from. Oh yeah. Sorry. He's just asking about local models and hardware we use and what we're doing on those. That might have been pulled from the OpenAI doc. We have talked about it internally. We've wanted to set up like a little bit of a cluster to run local models to like play around with, just because costs are kind of crazy right now. But the last time I checked, Mac Studio with the amount of memory we needed and how many of them we needed was like 6 months back order and was going to cost like 20 grand. So RAM is very expensive right now, and it's very hard to build like local clusters for local models, at least the good ones that are like valuable enough to do like decent agentic coding tasks, like a Kimi K26 or some of these other decently large open weight models. But I'm excited for where that's going, because I think there is a lot of potential to be able to use more local models. But yeah.
You mentioned that your developers merging. I wonder often what value I add to PRs. I often have the agents do all the merging up into an intermediary branch. They're able to do it. They can talk to other agents on GitHub. My question is really, what extra value, what is your specific process when you are manually merging it? And have you tried some sort of writer as well?
So the question was kind of around the PR process and the autonomous nature of like AI reviewing and like being a part of that process, and then humans also reviewing and manually merging. And are there other potential opportunities to even have more automation in that process? Is that what I'm understanding correctly? Yeah. Okay. Yeah, we've had discussions about what that might look like. We lean on like code owners a little bit, and we've talked about like even having AI agent code owners, where you might have a domain expert on your team that's like, they're really good at database design, and it's like every time you're making a change to the database, we would love to have this person's eyes on it. If we could capitalize on their time enough, we'd do that every time. But obviously, in a lot of cases, you can't with humans because our time is really limited and valuable. And so one of the things we've talked about is like, take one of those experts, create a custom like agent code owner for that area, and then have that expert actually tune and train that agent to think like they think, so that like you can actually take their expertise and apply it with an agent that they've tuned and reviewed over time to like catch common things that they've seen in other like PRs, and try to like codify that into like an agent itself, and do that for like various parts of the code base and the platform. And I think once we get to a world where we can do more of that, we'll have a lot higher trust in that process, to where we could start thinking about automating even more of that, and having like certain areas that are maybe lower risk being able to be approved by those AI agent code owners, that could then like on approval of those AI agent code owners could like merge without human oversight. And that would be that'd be a really interesting direction. I think that we could potentially go in the future. Yeah.
Tech develop, coding developer, like how would he go about merging his own PRs? What would that process?
Yeah, so if a non-engineer was in that process, how would they get their PR merged? I think in those cases, like we'll probably always want to have some engineering oversight for those that are not engineers like contributing, just because there's probably questions that they didn't think about asking that engineers would think about. And there's still, even when I showed that stat of 30 PRs in 5 days from someone, there was in that same time frame, there was also 5 other PRs that were just closed and deleted because they weren't valuable after like an engineer looked at them. And so like there are times where like changes do need to be rejected and like back to the drawing board or give more feedback, and then they can take that and try another pull of the slot machine handle, so to speak. But yeah, way in the back.
Extrapolating out that curve that you showed at the beginning of intelligence for models, maybe. I know for myself, I felt a very large gap between Sonnet 4.5 and then Opus 4.5 back in December. What's the last thing that we as engineers provide the most value in going forward if that curve continues to extrapolate out to, I don't know.
Yeah. No, I love this question. We at one of the recent lunch and learns we did, we actually had the CTO of this company ask us the question that was like, with all these agents writing all the code, like, why do we need to hire more engineers? Like, why would you not just hire non-engineers and have all these tools so that they can use to deploy? And our like argument and rebuttal to that was that like engineers need to design the systems and the platform to enable those individuals to ship code. Like I think engineers are like, we're gonna maybe focus less on actually building out the functionality in the product itself, and we'll focus more on the platform, the scale, the architecture, the technical debt, and trying to like keep a lot of that in check. And then when we answered that, he's like, well, if engineers can do all of that and they can do it all faster, then like, why not just hire only engineers and not hire anybody else? And the rebuttal to that was that like, well, those individuals in a lot of cases are domain experts. My co-founder has ran large sales organizations for like 20 years and knows so much of the ins and outs about how sales works and what makes a good like go to market and like sales and revenue team. And I don't know very much about that because like I haven't worked, like a lot of the companies I've worked at in my career weren't not in that domain at all. And so like I don't have that expertise as to like what the pain points are every day and the problems that we're trying to solve in our product. But his domain expertise is super valuable there. And so the cost of writing code and creating software is getting cheaper and cheaper, which allows domain experts to build more and more of that software to solve their own problems. But they're inevitably going to run into problems, whether it's security, whether it's scale, whether it's like all these things. And so like we're still going to have this same model where we're going to need domain experts, we're going to need engineers to like build systems to scale and solve security and like have the guardrails in place so that domain experts can actually ship more, which I think is actually really exciting to like have people that understand the problem even more get more involved in that process. Because getting an engineer to become a domain expert in a new domain takes a long time. Like you might think like the ramp up time on an engineer like in a code base is pretty quick, but like them truly understanding the domain and like the business problem that a company is solving takes a long time. At least in my experience. And so it's like, I don't know, it's kind of exciting and it's definitely a shift. And some engineers love shipping product. And so like what that means is if you love shipping product and don't want to focus on building platforms and security and scale, is you probably need to figure out how to become a domain expert in a specific area so that you can like ship more features into the product itself and less on those other aspects. But yeah. What else? I didn't see which one went up first, but Brian hasn't. It's Brian China, right? Okay, I was like, I thought I don't have my glasses, I'm nearsighted, so.
I'm curious about manual QA and how that fits into the process. For the company now that's very complex code base, so actually running that AI guides is really important. So I'm curious if you do a lot of manual QA with your stuff or part of this is going right.
Yeah, so the question is about manual testing with AI agents producing a lot of the code and how important it is for us to test it and how we do it. So like I mentioned, Ivan has a lot of skills that help us understand what does need to be manually tested. Some of the things I'm excited about with Cursor's cloud agents is that they gave the agents access to computers. So like Cursor's cloud agents can actually like run your app, open it in the browser, and actually like test it, and then not only just test it and validate it, but then they can send you a video of the whole test suite that it ran. So you can actually watch a video of the entire like manual test QA that the Cursor cloud agent did in that session, which I think is really cool. And I think that like that kind of tooling is just going to get better and better, and models are getting better at visual too. And like if you haven't tried some of the new computer use stuff with like either with Cowork and like Chrome like Claude Cowork and Chrome extension where it can control your browser, or Codex's computer use, it's really impressive how well it can just control any application on your computer, and can like given an outcome, it can go and like do a thing, and whether that outcome is like test this functionality of the app and then like make sure that that's working. But yeah, there's also like tools with Playwright CLI and MCP server to give your agents access to those to like go and test them. But yeah, there's a balance there between like automated end-to-end tests versus like manual QA, whether you're doing it manual QA or an agent is doing it manual QA. And yeah, it'll be interesting to figure out how that shakes out of like what the right ratio is there. It's like how much should be automated end-to-end tests versus like having the agent just QA it and send you a video from the cloud agent. But yeah. You
mentioned having the database expert train or tuning an agent. Is it them making a skill, then rerunning it over and over again, testing it?
Yeah, I think it's funny to think about it this way, but my co-founder actually suggested it to me, and I love the concept or idea. Is like, if you're a senior engineer and you have someone in your team that's more junior and like you're managing them, like what do you do to help like train them? You have one-on-ones, and he suggested like we should have AI agent one-on-ones. Like we should basically go and review like an AI agent's like output for the last like week or two and like review it and say like where did it go wrong, where did it do well, like what do we need to change like in the skill or the instructions for it to like get the right outcome, and review that on like a consistent basis, just like you would an employee to like level them up and get them to like contribute more and produce more value. You do, I think, doing the same thing with agents, and whether we call it an agent one-on-one or not, but it's kind of fun to think about that way. But yeah.
I listened to the podcast with Boris Turney. He's had a few recently.
Yeah.
Creator of Cloud Code.
Yep.
And he talked about the way that he uses the Cloud Code a little bit, where he keeps his Cloud.md file really minimal, only things that he notices repeatedly, and then when it gets too large, he just gets rid of it all and then starts from scratch. I'm wondering like what kind of agents.md or Cloud.md you guys have. How does that change, and how do you make sure that it applies across models, like general principles, or do you kind of tailor some things like Cloud.md, for example, you're probably tailoring just to the Cloud model, but agents.md might be more general. How do you guys like look at that and apply that?
Yeah, so it's how do we enforce, the question was how do we enforce like consistency in like our agent instructions, whether it's agentmd, CloudMDs, to kind of scale that up through our code base and enforce that consistency. So our Claude MD files are basically just symlinks to our agent MDs, so we only have to manage one, which is nice. And we also like our AI code review bots. Like for example, we use BugBot or Cursor's BugBot as one of our AI code reviewers, and it has a feature where it actually learns from code review. So like if you give it feedback or you have a CI check that fails, it can actually like teach itself and add new rules to itself to like in the future, hey, this check in CI is going to catch this issue, so I might as well just like look for it in code review and flag it with a comment. And then we've kind of I've played around with a couple of times. I got the idea from Boris as well, where like you're reviewing something in a code, like in a PR, and you see a behavior or a pattern that you don't think should be happening, you can actually just kick off a cloud agent to like go and fix that thing in the agent instructions, where you're like, hey, I don't like this pattern. I don't know if we're actually explicit about this in our documentation for the agent, but let's go check that. And if we aren't, let's add some more explicit instructions to say like let's not do that. We also don't use just a single, because it's a mono repo and it's fairly large, we don't just use one single agent MD at the root of the repo. We actually have one for like each project. And we even sometimes go more granular if there's a specific part of our code base in a project that's like very complex. We'll even have like a local agents MD in that directory that's like even more specific to that area of the code base that's complex. Because agents will look at like the closest local agent MD to where it's making changes to it to like read those for context. And another interesting thing I saw recently is Vercel published a report about like a benchmark they did with agent MDs versus skills, and they found that skills were much less often found by agents that were like writing code than they were like agent MDs. And they found it was even better to just like, if your agent MD even was just a list of like file paths to other files, because one thing that's important for agents is it's called progressive disclosure, which basically means like, don't give it all of the context up front, because then context rot, right? And so we want to give it like a high level, but then give it places to dig deeper, where it's like, hey, if you're going to be working on, in the React front end, go look at these other deeper instructions for how to work in the React front end web code base. And so you'll have like another file that goes more in depth on a specific topic, or, oh, hey, you're going to add a database migration, agent MD, here's the instructions for that you should go read whenever you're doing database migrations that has more details as to how to do that well, right? And so like you can create like these tree structures of like top level agent MD that then points to other documentation files that are more in depth and more detailed. And that allows the agents to like more dynamically discover those instructions and only pull them in when they need to, so that you don't get bad context rot that eats through like your whole context. Yeah.
So just building off of that, today I was using just Claude Code and I had the GStack kind of hold like architecture built in. And after my very first chat, I was already at 120K token usage because it was pulling in every single skill from GStack, and I'm not using it. So, but one thing that I saw on too is that it turns out that CLIs are kind of now the fad, where it's like the CLI, you just tell your agent to, whenever you need to do something like with the Obsidian CLI, it runs the help command, which then shows all the commands it has access to. So it only actually gets that context at run, rather than when you actually start your chat to blow your target context.
Yeah, and I think one of the things that kind of like popularized CLIs was like OpenClaw. Because like if you haven't followed that super closely, Peter Steinberger, the creator of OpenClaw, notoriously has been like anti-MCP, and he has a tool that he created called MC Porter, which literally takes an MCP server and automatically ports it to a CLI, because he doesn't want to give his agents access to MCP servers, and he'd rather give them just CLIs because they're really good at using computers and file systems. And so like just giving them command line tools, they're actually very good at like utilizing them and understanding how they work and everything. So yeah, I would agree with that. Like CLIs seem to be the thing, and it's not just in my opinion, I don't think it's just hype. I think there's actually been a lot of value by switching to CLIs in a lot of cases. Yeah, again in the back.
This was kind of going to reiterate on that. The primitive that a lot of agents really seem to thrive in is file-based architecture, right? Just because it's been trained into them so heavily by, that's the way that almost all computers work. So it becomes a primitive that's really easy for them to traverse and understand the hierarchy. A lot of subtext in a file tree that we don't really think about, but it's native how it's structured, where this is dependent on that, and just by the structure of the data, that other tools would not just by the exposure. So
Yeah, I would agree. Yeah, we've had a lot of questions in here, but I know we're at 8:35. I also want to have time for people to just kind of like more mingle and network as well, and have even just your own conversations. I guess we could do a couple more questions if anybody has any, or discussions. Yeah.
A year ago, I had great deep knowledge of coding. Nowadays, I'm developing in Rust, and I don't know any Rust. And there's a huge gap about my knowledge and what I'm creating. My question is, what tools and policies do you have to measure and decrease this knowledge gap?
Okay, so the question is around like, as we have agents writing more of our code, we're becoming less familiar with the code bases that we're working in because the agents are the ones working in them, not us. And what tools or processes can we do to help reduce that gap in knowledge in those code bases? I recently heard this. Some of you might be familiar with Theo on YouTube. He was the creator of like T3 Stack and stuff, but he does a lot of YouTube videos and talks about tech and a lot of AI stuff. And one of the recent videos, he talked about how he drew this comparison to like skateboarding, because he's a skateboarder, and he was like, I learned that, or like most people that try skateboarding will stop and abandon becoming a skateboarder before they even learn how to like ollie or do a kickflip. And he's like, because it hurts really bad to like see other people doing all these things so effortlessly around you, and you trying and failing so hard so many times just like hurts like our ego and our pride, and it's like really hard to overcome that for a lot of people. And the more we adopt and use AI, one thing that we're realizing is that like we have that same pain when it comes to like learning something new in a code base, a framework, a new library, where like previously you had to put in the effort to like dig through documentation, like understand how it works, how to integrate it into your system. And like there was this hurdle and like pain, and like sometimes when that went wrong, the pain was not physical pain or like hurt your pride, but like you would feel dumb sometimes when like somebody smarter than you was like, oh, why are you doing it that way? Like you should totally do it this way instead. And I think with AI agents today, we're losing some of that, like that hurdle that we have to cross over, like feeling that pain. And it becomes so much easier and less painful to just pull the slot machine again, right? And just like tell the agent, that didn't work out well or the way I wanted it to, let's just try that again. And it's easier to just keep doing that and not feel the pain than to like spend a little bit of time and effort to try to like understand and learn how something works, like whether it's a new tool, a new platform, or something else. And I think that like in my head, that's kind of how I'm trying to like prevent myself from creating that gap. Is it like, rather than just pulling the slot machine lever and having the agent go and build it, like I start by like, one of my favorite skills is from another YouTuber guy, like Matt Pocock. He's like they call him the TypeScript wizard. But he created a skill called Grill Me, and it's basically like you just do /grill me when you're talking about like a plan, and it will just hammer you with questions where it's like, it basically is like, make sure I know what I'm talking about, make me feel dumb. And I have actually found that super valuable because it helps me, like I said, my goal is like, I want to feel dumb sometimes. Like that's how I know I'm learning, is like, if AI is just solving all the problems all the time, then like, I'm going to just get used to it solving my problems for me. And I don't want that. I want to still continue learning. And so I think we need to make sure to like spend the effort to do that and like not get too used to just on the slot and letting it go again and hoping that it works better the second time. And like sometimes if it doesn't work a few times, you got to spend the effort and get over the pain of feeling dumb and like, oh, well, I thought I knew what I was doing here, but I guess I don't, and that's okay. So I guess that's my advice for that.
To contribute to that a little bit, I think one thing that's helped me is reviewing my own PRs really thoroughly right after I make that, even as well as I think I know the code that I just wrote, like pure, like assisted with AI. No matter how well I know it, when I go and I treat it, I kind of wipe my mind and I treat it as if I'm reviewing. I've seen the code for the first time. My own code, right? I'm like doing a pull request review of my own code, blank slate. Could I pick this up and review it in 5 to 10 minutes? And if I can't, then I either need to add some comments to the review, or I need to make the code clearer so that whoever does come after me and actually is doing a real review can pick it up and do it correctly. That closes that gap for me a lot, where it closes that knowledge gap, where I understand the code I wrote so much better.
Yeah, I'm back.
Add on to that, like ownership isn't going to go away. And I think if we can hold ownership of code that we write or that agents write for us, like we are going to be a lot more successful because we will understand the system we're building. It's not about the, like maybe the granularity anymore, but it is about understanding the system that we are architecting. If we give that ownership up, we are not engineers.
Yeah.
Kind of build off that. My uncle is a software engineer at Intel because he's in charge of their verification validation. The code, his code specifically like generates the like infrastructure of the chips, right? And he says that his engineers based in India will, I mean, they'll just like everyone else, they're all using Claude and whatnot. But if there's ever a bug, he'll like push it back to them, and he says that one of the issues he has with his engineers is that they don't take ownership of it, right? And if you're writing, you know, or you're having your agents write your code, and then you just kind of put the blame back on the agent, saying, "Well, Claude wrote it," then like we're hired to like solve problems, right? So we should look at like at least be some sort of or somewhat aware of it.
Yeah, there's actually, I'm gonna see if maybe I can find it really quick. No slop. This is actually a site created by somebody local here in Utah, but it's called No Slop AI. You may have seen the alternate version of this that's for like Slack, where people say like, it's about like, don't send somebody just like a hi in Slack, or like, don't give them the context when you're asking. This is like the equivalent, but for like people generating AI output and then like dumping it or sending it to somebody. It's called like own your output, don't send slop. And like, I love this manifesto that like effort is the message. When you forward something you haven't read, you're telling me my time is worth less than yours. Volume isn't value. 6-paragraph response to a yes/no question isn't thoroughness, it's noise. Your name, your words, whatever tool you use to generate it, once it leaves your fingers, it's from you. And then read it, trim it, own it. If you can't summarize it in your own words, you're not ready to send it. And I think even though this is applying to just like how we communicate with each other in like Slack or email, where we're using AI to generate like a lot of messages, I think it also applies in a lot of sense to like code as well, right? Like in a lot of sense, it's like, yeah, once you use the tool to generate it, like that, it's still, even though an agent wrote it, like it's now yours. So of that, but yeah, last one.
Yeah, one more comment on that. So I use AI a lot more for just generating code. I ask a lot of questions, say, where can we solve this? Then think you're going to pick one that's best, or how's the code base? Basically, that with the code base for security or for performance or kind of thing, and generate diagrams for me. And it's really good for understanding code base.
Yeah, it's actually using AI to learn is kind of underrated. I think like, you can just give a task to AI, but like if you want to understand the thing you're doing, like using AI to understand it first is also really helpful and valuable. So yeah, I agree. Okay, so before, for people that want to mingle and chat some more, here's just a couple of QR codes for like if you're interested in submitting a talk in the future on a topic. We'll probably do some that are going to be like lightning talks where we'll have like a couple of short ones. So if somebody wants to do shorter talks, but then we can have some like longer talks as well. And then if somebody's interested in wanting to help sponsor a future meetup, there's also a sign up there on that QR code. And then, we talked about Utah.js. You can go join that for free. There is an AI channel and a meetup channel in there. And that's the end. So I'll just leave these up and let people chat, or if you need to take off, you can take off. But thank you everybody for coming for the kickoff for this, and I'm excited to keep going. So.